Hi, everyone, and welcome to our zero-day quest training session focused on the MSRC AI Bug Bounty Program and AI security research. We are really excited to have you all here. My name is Aideen, and I'm an AI security researcher on the MSRC Vulnerabilities and Mitigations AI security team, and I'll be your host for today's training session. So this training is a part of Microsoft Zero Day Quest, which is our public research challenge running until mid-January. And this training today is specifically relevant as we are doubling all of our AI bug bounty rewards as part of Zero Day Quest. And this is because we really want researchers like you to submit high impact AI security vulnerabilities. And it's still early days relatively in AI security research, and we hope that this training will help you understand the type of vulnerabilities we care about and how they are perhaps different to the classical vulnerabilities you might have previously submitted to bug bounty programs. So our trainers today are Andrew and Lynn, both of whom work directly on the AI bug bounty. And if you have questions for them or the AI Bug Bounty team throughout the training, please put them in the live Q&A feed, because after the core training session, we will move to a live Q&A with Andrew and Lynn. So definitely make the most of your next 60 minutes with them. So without further ado, I will hand it over to Lynn and Andrew to introduce themselves and begin your training.
Awesome. Thank you so much, Aideen, and thanks everyone for joining us today. Andrew and I are really excited to be here to chat with you all about Microsoft's kind of approach to researcher incentives, most notably our bug bounty program, the AI bug bar that we released last year, and how to even submit a report to Microsoft. And then, as Aideen mentioned, we'll have some time at the end for some Q&A, and we'll have some folks answering questions in the Q&A panel as well. So my name is Lynn. I'm a program manager on the researcher incentives team in the Microsoft Security Response Center. And along with my team, I lead the Microsoft Bug Bounty program and the Microsoft Researcher Recognition program. So my focus is largely on the Microsoft, like the Windows Bug Bounty program, and then most notably, or most recently, creating the AI Bounty program. So I've been at Microsoft for about 5.5 years, first managing external security events and conferences such as Blue Hat and Microsoft's Black Hat celebration, and I've been on the Bounty team for the last 5 years.
And hi, everyone. My name is Andrew Paverd. I'm a research manager also within the Microsoft Security Response Center. I lead the vulnerabilities and mitigations team that's specifically focused on AI security vulnerabilities. So any of your reports of vulnerabilities in our AI products or services will come to myself and my team, where we work to reproduce them and assess the severity of these vulnerabilities. So I've been at Microsoft just over 6 years now. I've been here mostly in a research capacity, but more recently I've been very much involved in the day-to-day operations of our AI vulnerability response. And I was the lead author of Microsoft's AI security bug bar, which we'll talk more about in today's training. But with that, back over to you, Lynn.
Thanks, Andrew. So as I mentioned, I'm on the Microsoft Researcher Incentives team. And here, my team really focuses on bringing in research that is of the highest impact to our customer security. So our researcher incentives are largely made up of monetary and non-monetary programs. So first, there's the non-monetary programs, which is the Microsoft Researcher Recognition Program. So this program offers public thanks and recognition to security researchers who submit a vulnerability, which in turn helps us protect our customers. While researchers are submitting the vulnerabilities, they're submitting it to the MSRC under coordinated vulnerability disclosure. So within this program, researchers will earn points and for any important and critical severity issue that they're reporting. And this program is made up of our quarterly leaderboards, as well as our annual most valuable researchers list. That also includes our coveted announcement around the Black Hat period of time, where we recognize our top researchers from the past year. So anyone who submits a vulnerability is eligible to participate in this program. And you can find more information on our program page, which is linked here in the deck that will be shared out, but we'll also put a link here in the Q&A chat. So next we have our monetary incentives, or our Microsoft Bug Bounty program. So our Bug Bounty program offers monetary awards to incentivize external security researchers to find and confidentially report high-impact security vulnerabilities that in turn help us fix security issues and protect our customers. So essentially, we're putting these big wanted signs across the internet, telling anyone and everyone what kinds of vulnerabilities we're looking for and how much money you can be awarded. So we offer bounty awards up to $250,000, which is about 2 to 10x higher than the industry averages. So our bounty awards are priced based off of a few things, not only the industry averages that I mentioned, but also the security maturity of the product or service, the security impact, and even the severity of the issue. And now our bounty programs are not a replacement for the traditional internal security investments that teams will be doing, but it's meant to be in addition to things like pen tests and traditional red team operations. Our Microsoft Bounty program covers a lot of Microsoft's vast attack surface. So ranging from products like Azure to Microsoft Teams to Windows, which is near and dear to my heart, and to our newest, which is Microsoft Copilot. So only a portion of the reports that are submitted to the MSRC are actually going to be eligible for bounty awards. Now, along with driving this high impact security research, my team also builds and manages relationships with security researchers and industry partners to identify customer threats and emerging vulnerability patterns. So we then take these patterns and insights and share them with our engineering teams across the company to drive security investments beyond one-off bug fixes. So we work with teams like our Microsoft Offensive Research and Security Engineering team, or MORS, our M365 AppSec teams, and those are really just naming a couple. So we use, along with these teams, we provide them this bug bounty data to surface these patterns and vulnerability trends. And that helps them in turn improve things and refine static analysis and really drive security investments beyond these one-off bug fixes. So why should you hunt on Microsoft's attack surface? Well, over the course of 1 year, this is from July 2023 to June 2024, Microsoft awarded $16.6 million to 343 researchers across 55 countries. And now, as you may have heard, we launched a bounty program last year focused around AI, so our Microsoft Copilot. So one of the most interesting things that's part of my job is really being able to grow and iterate and evolve our bounty programs to help Microsoft customers stay ahead of the curve in this changing, very rapidly changing security landscape. So with the announcement of Bing Chat in, let's say, early 2023, what we now call Copilot, we knew this would be an exciting and really quickly evolving security research space. So the AI Bounty program comes as a key result of a lot of internal security investments and learnings throughout 2023, including not only an AI security research challenge, but also the new AI bug bar that we'll speak to in a bit here. So this AI Bounty program focuses on vulnerabilities in Microsoft Copilot. And as we announced in our Zero Day Quest blog, we have doubled the AI Bounty programs to now have the AI Bounty program awards to now have awards up to $30,000. So really think of the scope for this program to be things like your copilot.microsoft.com, the Copilot AI experience that's in your Microsoft Edge browser, or the iOS or Android mobile applications. And so, as I said before, our programs are constantly evolving and changing and iterating. So be sure to kind of keep a lookout on our LinkedIn, our X, or MSRC blog to see any exciting changes that are coming your way. So let's really get into the types of vulnerabilities that are eligible for bounty awards under this bounty program. So vulnerabilities that are assessed as important or critical severity in the categories that are detailed on our AI bug bar are going to be eligible for bounty awards. Now I'm going to pass it over to Andrew, and he can speak a little bit more to what these vulnerability categories are, how we classify the different severities, and in turn, our AI bug bar. Over to you, Andrew.
Thanks very much, Lynn. So yeah, as Lynn mentioned, we're very excited about this new space and all of the possibilities to see interesting security research around Microsoft's AI products and services. And as Lynn shared, one of the key things that we use when deciding on bounty awards is the bug bar. Now, you may have seen something about this bug bar in the previous training that we ran for the zero-day quest, but in this training, we'd like to really do a deep dive into what is in this AI bug bar, how do we use it, and how does this apply to the research reports that you can submit to us. So firstly, what is the AI bug bar? This is an extension of all of the existing bug bars that Microsoft has. So bug bars related to Windows and online services that you may already know about. And we've looked at what was potentially missing from those that is specifically required for AI in terms of the new products and services. So this new AI bug bar is meant to be a complement to the existing bug bars. You'll find that there's nothing overlapping between them, but this is a way that we can define new vulnerabilities that might arise through the use of AI in products or services. So specifically, the bug bar defines the vulnerabilities themselves. What precisely do we mean by each of these vulnerability types? And we'll go into that in a lot more detail over the next 20 minutes. It also explains how we assign severities to these different vulnerabilities and what it means for something to be higher or lower severity. As I say here, this was first published back in August 2023, and we've actually updated it since then in June of this year, 2024. So all of this is public. You can find the details at aka.ms/AI bugbar. And before I dive into all of these new vulnerability categories, to set the scene, we really need to talk about the big new thing, the new thing that's changed since 2023, as Lynn mentioned, with the introduction of Copilot and specifically around large language models. And that relates to instruction-tuned language models. So here's a little bit of background about that and how we can think about them. In an instruction-tuned language model, the outputs, as you would expect for a generative AI model, can be any type of text or audio or images or video. And critically, the inputs contain the actual instructions to the model itself. So in contrast to previous generations of machine learning models that had to be trained for a very specific purpose, an instruction-tuned model is able to adapt on the fly, to change its behavior in response to instructions that are provided at inference time. So as I'm showing here on the left of the slide, the inputs to an instruction-tuned language model typically consist of at least three elements. Firstly, there's the system prompt. This is a set of instructions that's provided by the model designer. This sets the initial context for the model, as I'll show in the next slide's example. In addition to that system prompt, the user can often provide their input or their question. So you can think about this like the question you're asking Copilot. And then there may be some additional context that gets provided to the large language model. And all of this gets concatenated together to be fed into the instruction-tuned language model to produce these outputs. So here's a more concrete example. On the right-hand side, I'm showing a simple chatbot that I created with Microsoft's Azure OpenAI service using chat completions. You can see I'm the first person who's asked that message, "Hi, what's your name?" And the bot has replied, "My name is MSRC bot. I'm an AI assistant that helps people find information about the Microsoft Security Response Center." That's MSRC. So how did I do that? Well, here on the left-hand side, I'm showing the inputs and outputs of that particular bot in text format. So in the blue, I'm showing both the system prompt, here denoted by role equals system, and as part of the system prompt, I programmed the model to say your name is MSRC bot, and MSRC stands for the Microsoft Security Response Center. And as you can see, that's then concatenated with the user's question, here denoted by role equals user. And that's exactly my question. Hi, what's your name? To which the model replies, as you see here in the chat. And so it's this combination of system prompt and user query that allows the model to generate this particular response to my question. So let's take another example. If, for example, you're using Copilot in the Edge sidebar, as I'm showing here on this slide, you may be visiting a particular web page. In this case, I'm literally visiting the web page on large language models. And I ask Copilot, please generate a page summary of the page that I'm viewing. So as you'd expect, that would be my user prompt. And the additional context is the entire text that the web page is providing. So all of that text can be converted into a form that the large language model can process, so removing some of the HTML elements, and that gets fed to the LLM as the additional context for my query. And so all of this gets concatenated together and fed into the model. And this is what would allow the Copilot to generate a summary of the page that I'm visiting. So of course, from a security perspective, you might ask, well, what happens if this additional context, for example, becomes attacker controlled? If an adversary can manipulate some of the input that's going into the instruction-tuned language model. And this is, of course, the phenomenon that's recently become known as prompt injection. So one of the earliest examples of this was from this professor from Princeton, who on his web page has his biography, as you can see here, but right down at the bottom, a very classic trick of white text, as you can see, color white text on a white background. So this text that I'm highlighting wouldn't be visible to the user who's browsing this web page, but it may still be visible to a large language model that ingests the text of this biography. And so here, the instruction was really trying to convince Bing Chat at the time, to change its answer somehow, to include a certain word somewhere in the output. And so this is an example of attacker-controlled input trying to modify or repurpose the system or the large language model to perform some other or some additional task. But all right, you might say, this sounds fine, but we're just modifying the output of the language model. Where's the security impact in that? Well, it wasn't long before other researchers started to notice that this could be used for various other things that do have a security impact. So here's another example. This is by Johan Rieberger, the author of the Embrace the Red blog, who's one of our top AI security researchers. And here, the example is showing how the same type of prompt injection via a web page could be used to cause the large language model to render a certain piece of text. Here, this text in Markdown format, which will ultimately be rendered as an HTML image tag. Here you can see an image tag with a certain source parameter. Now, the trick was that this source parameter could be an attacker-controlled server. Here, for example, attacker.com. And so when this image is rendered, there would be a GET request to the attacker's server, which could potentially leak some information. And indeed, this was the whole idea of this data exfiltration exploit, that the prompt injection caused Copilot to look for any sensitive information on the web page or in the user's preceding conversation, encode it as part of this URL, and then cause it to be rendered as an image tag, which would exfiltrate the data ultimately to the attacker. So that closed the loop and showed a clear security impact through prompt injection. This was duly reported to MSRC and fixed, and you can find all of the details here in Johan's blog. A more recent example, just to illustrate that this doesn't only happen via web pages, was also from a more recent blog from the same researcher, where an email that's received by a recipient could contain similar types of prompt injections. And here, this was demonstrating how the prompt injections can be hidden in other clever ways, in this case, using non-printable characters rather than white text on a white background. The point being that there are several ways in which prompt injection could take place, and part of the security research challenge is to try and find out these different ways of where prompt injection may take place. This is a very new space, and so we, along with the rest of the industry, are also learning how best to secure systems against this new type of vulnerability. So that was a very high-level introduction to one specific type of vulnerability, but I hope it sets the scene for talking about these new vulnerability categories that we've defined as part of the AI bug bar. So essentially now the question is, what's new in the AI bug bar? The answer is these three new top-level categories of vulnerabilities. So firstly, we have inference manipulation. This is a category of vulnerabilities that manipulate model responses at inference time. So they don't change the underlying model, they don't change the underlying system, but they somehow interfere or manipulate a single inference request. You can think of it like modifying a single user session. In contrast, the second category of model manipulation is around anything that modifies the underlying model itself. So something that caused a change to the model, perhaps when it was being trained or fine-tuned, but this change that ultimately affects all users of the model. That would fall under the model manipulation category. And the final new category is called inferential information disclosure. So for those of you coming from the security research side, this will be quite familiar in the sense of it's very related to information disclosure, which is unauthorized access to information. But here we draw a distinction of inferential information disclosure, which is anything that could be inferred through the use of a model itself. So through the inference interface that I was just showing on the previous slides. So let's dive into what specific vulnerability categories we're defining in each of these new top-level categories. We start with inference manipulation. And here we have two main vulnerability types, prompt injection and input perturbation. So prompt injection, exactly as I was showing in the previous examples, is defined as the ability to inject instructions that cause the model to generate some unintended output that leads to a specific security impact. So here we're talking about instruction-tuned models, and we're talking about instructions that are injected not by the direct user of the model, but through some other path. So the attacker is not the direct user of the model. And so here, the severity of these vulnerabilities depends on the security impact of the prompt injection. If, for example, you're able to find a prompt injection that can have some immediate impact without any interaction from the victim, so for example, a zero-click exfiltration of data or performing some privileged action on behalf of the user without them having to do anything, that would be a critical severity vulnerability. In contrast, if the user needs to do something like click on a link or go through one or more steps, that would decrease the severity slightly. But in contrast, again, if there's no security impact, if you're just able to manipulate the output or change or influence the output in some way, that is something we refer to as a content-related issue. That's not currently in scope for our current AI bounty program, but it's still something that you can report to us via the same processes that we'll discuss at the end of this talk. So that's prompt injection, and that's really the new thing that we're seeing quite a lot of with our new AI products and services. In contrast, the input perturbation is a much older, much more well-studied class of AI vulnerabilities. This is sometimes known as model evasion or adversarial examples. And so for any of you coming from the AI security research space, you'll be quite familiar with this. This is the ability to generate valid inputs that cause the model to produce some unintended output or incorrect output. And again, the severity depends on whether you can have a security impact and how much interaction is required from the victim. So those are the two main vulnerability types within inference manipulation. And again, note that we're not changing the underlying model, but we're simply manipulating the inference in a given session of interaction. Moving to our second category of model manipulation. So these are the things that are really changing the underlying model. And here we have really one new vulnerability type. This we call either model poisoning or data poisoning. It's the ability to poison the model by tampering with the underlying architecture, the training code, the hyperparameters, or the training data, such that the model itself is tampered by the adversary. So here, again, as you'd expect, the severity depends on how this impacted model is used. If, for example, it's used to make decisions that affect other users, then it would be a critical severity vulnerability. But if it's only used to make decisions that affect the attacker themselves, this would be a much lower severity issue. So depending on what model can be poisoned, if it's a model that's used by other users, that's definitely something that ends up with a higher severity. So that's the new vulnerability type in model manipulation. In the final category, we've actually got 2 slides worth of vulnerability types because there are a couple of different things here. I'll start with inferential information disclosure that affects training data. So this is any data that was used to train the model or fine-tune the model or in any other way to create the model. And there are a couple of different types of inferential information disclosure here. Perhaps the most obvious and intuitive is training data reconstruction. So if an adversary is able to reconstruct individual data records that went into training the model, for example, like getting back the things that were used to train a particular image classifier, that would be an example of training data reconstruction. And you can see that with all of these, the severity depends on the data classification of the training data. If this was highly confidential data that was used for training, this would be an important severity vulnerability. But if it was trained on public data, that's a lower severity vulnerability. So the other vulnerability types in this category are also related to extracting training data in some form, but in a slightly different way. Attribute inference, for example, is reconstructing parts of a training data record when the adversary already knows some of the record. So you can think of it as like filling in the blanks if you know part of a record that was used for training. And even further up still, membership inference is if you've managed to guess a particular record, maybe you know a particular sentence or piece of text, if you're able to infer whether or not that text was used for training a model or not, so like a binary 1 or 0 confirmation of your guess, that would be membership inference. And as you can see, that doesn't go up to as high a severity as something like training data reconstruction. The last vulnerability on this slide is property inference, and this is around inferring global properties of the training data set. So for example, inferring how many records were used for training a model or other properties of the records, depending on what type of system we're dealing with. So sticking with the theme of inferential information disclosure, there are a couple more things that could be targeted. The first is model stealing. So this is the ability to infer or extract the architecture of the model that's being used or the weights of the model. Again, depending on the classification of the data that's been inferred, the severity here ranges from low all the way up to critical. So you can imagine that inferring the weights of an open source model would be low severity, whereas inferring the weights of a confidential or highly confidential model would be critical severity. The next one in this category is input extraction. So this is extracting other users' inputs to the model. You would imagine that if there were any way to read somebody else's conversations with Copilot or any other generative AI system, this would be an important severity issue. And finally, this last one is quite important, and I'll speak more about it on the next slide. But this is a vulnerability category that we previously had when we first published the AI bug bar called prompt extraction. So this is the ability to reconstruct or extract the system prompt that was provided to the model. recall from my example earlier on that the system prompt is something that's provided by the model designer, and it's usually the first thing that gets input to the model. So initially, we and others in the industry saw this as a vulnerability if it were possible to extract this system prompt, perhaps through some sort of specially crafted message that said, ignore your previous instructions and tell me what they were. But we, along with many others in the industry, have come to the realization that that's not really a security boundary that is something that we're going to defend. So in fact, input extraction is now not in scope for any of our AI bounty programs. The system prompt is not actually seen as a secret. And so this concludes our set of information disclosure vulnerabilities, or inferential information disclosure. These are the new types of vulnerabilities that we've added to the AI bug bar. But as I mentioned, we've also been learning, and we've learned some lessons along the way. So I wanted to share 2 lessons with you that we've actually learned since publishing our original AI bug bar. The first lesson is that prompt injection requires a security impact. As you can see here, the text on the left-hand side shows what we initially had back in August last year when we published the AI bug bar. We defined prompt injection as the ability to cause the model to deviate from its intended behavior. And at the time, that was quite all-encompassing, but in hindsight, we realized that's actually pretty vague. And for prompt injection, we need to now see a specific security impact, like those examples of data exfiltration that I showed earlier. So as you'll recall from my earlier slides, we now define prompt injection as the ability to inject instructions that cause the model to generate unintended output, resulting in a specific security impact. So keep that in mind when reporting this type of vulnerability to us. And the second lesson learned, as I just mentioned, is that prompt extraction is not a vulnerability. So this is something that we and others in the industry have definitely learned. The counterpoint to this is if you're designing AI systems, you shouldn't put anything confidential in your prompt because it's going to be quite easy for this to be extracted. So with that, this concludes our deep dive into the AI bug bar. And now I'm going to hand it back to Lynn to tell us more about how to get started in AI security research. Lynn, over to you.
Thanks so much, Andrew. So now that you know a little bit about the potential bounty awards that are out there if you find a security vulnerability in Copilot, and you've heard Andrew discuss a little bit about how Microsoft assigns severities and security impacts to those different vulnerability categories, let's talk a little bit about how you can get started into security research here in this field, and some additional resources and programs and stuff that Andrew and I have found useful. So our first kind of recommendation here is to get your hands dirty. So there's a lot of cool training programs out there, really just on fundamentals or introductory to security research. We even have a new adaptive prompt injection challenge called LLMail Inject that Microsoft announced just a few days ago, honestly. And this is a great learning opportunity and playground for you to get an introduction into prompt injection. And then you can use these skills that you're learning throughout this challenge to kind of level up and find and report vulnerabilities, really looking for that AI bounty award. A couple other recommended training programs or events are things like Bugcrowd University, HackerOne's Hacker 101. And then our next recommendation is really around conferences. So this is a great learning resource because you can not only attend conferences in person, meet and network with other folks in the field, but you can also attend them online or virtual, which are a great way to kind of stay up to date and get that content. So we have a quick shameless plug here, but Microsoft's Blue Hat Conference, which just happened a couple months back, actually had some really relevant talks on AI vulnerabilities and security research and AI red teaming. And each year we host Blue Hat and really curate sessions based on the emerging technology and trends. And you can find a lot of the recordings from the Blue Hat Conference from this year and from years past over on the MSRC's YouTube channel. So again, we'll drop a link into the chat. So next, our next recommendation is reviewing research papers on arXiv. So this is a hub for technical and academic papers where you can find information on security, AI security vulnerabilities, as well as defenses against these types of vulnerabilities. Our next recommendation is books from security experts. This is another really great resource for catching up or staying up to date with what's currently going on in the industry. And another little plug here, one of our colleagues recently published a book, not with a bug, but with a sticker, Attacks on Machine Learning Systems and What to Do About Them. So that was written by Ram and Hiram, and Ram actually did the last training session for Zero Day Quest. And so finally, a couple last recommendations here. One would be to review any vulnerability reports and blogs from other AI security researchers. We've even noted a couple of blog posts from Johan a little bit earlier in Andrew's section of the talk. And being able to read through how another researcher has approached finding a vulnerability in this space is a really great way to not only see and kind of get a different perspective on how another researcher has approached this kind of problem before, but you can really use or even improve on those attack patterns in your own security research. And finally is reading the documentation and all the numerous pages that Microsoft has provided. So one is on learn.microsoft.com. Here you can get documentation about all of the products to better understand the expected behavior, or even the different features, or what flags you need to turn on to get the admin features and that kind of stuff. And then the second is the MSRC documentation that we've provided on our different bug bars. So as Andrew mentioned, we have not only this AI bug bar that we kind of went in depth about today, but there's also one focused on online service vulnerabilities and another one focused on Windows or more product side vulnerabilities. So now that you know a little bit about the BIOM program and you're really interested in getting started with your security research journey here, how do you submit a report to MSRC? So first, you're going to go to aka.ms/secure-at, and this will take you directly to our Microsoft Security Response Center researcher portal. So here within the portal, you'll get a submission form. And so within this submission form, you'll include information like what type of vulnerability did you find, what product is affected, and even a proof of concept. So for the proof of concept, whether it's a video or screenshots or written steps to reproduce, all of this information can really help our teams investigate the issue as quickly as possible. And so, like we've kind of mentioned a few times throughout our talk today, there's standard processes and stuff for traditional software vulnerabilities, but we have a few differences when reproducing and assessing AI-based vulnerabilities, and a few tidbits of advice to include into your report to really help the team be able to reproduce and assess the vulnerability that you're submitting even quicker. So the first is, listing out the exact URL or application of Copilot service that you're interacting with. The next is making sure you're including any choices that you made when setting up your Copilot service, and including the text of any prompts that you've entered. So both, in an image or a video, as I mentioned before, or you can even just kind of copy and paste that text into your submission report. And then the last couple here, I'll kind of group these together, is one clear evidence of the reported behavior. So again, like the proof of concept here, the screenshots, the video, or even the conversation ID. And then kind of writing up how consistently you saw the behavior. So, whether you reported this one time or 10 times or 100 times, that information really helps our engineering teams be able to investigate, do they need to try it 1 time, 10 times, or 100 times? And then if possible at all, if you can provide proof that the issue isn't a result of a hallucination, again, this will just help our teams better understand the vulnerability or the issue that you found even quicker. So we shared a lot of resources today throughout our talk, and I think we've got a few links already in chat, but this is kind of just a summary of some of the links that we shared throughout our talk today. And again, they'll be pasted in chat, and you'll be able to see this deck via our LinkedIn. And thank you so much, everyone, for joining in and for your time today. We really appreciated the opportunity to chat with you. And I'll turn it over to Aideen. I think we'll have some time for Q&A here.
Great, thank you both. And we can move to the Q&A part of this session. So the first question is for Andrew, and it's asking about the process of creating the first AI bug bar. So how did you decide which vulnerability categories to include, and how have things evolved since then?
Oh, that's a great question. Yeah, thanks to whoever asked it. It was, first to say, it was very much a team effort, involving so many people in so many different teams across Microsoft. But broadly, what we wanted to do was bring together all of the experience and institutional knowledge that we had, and indeed that various others had, across the industry, across academia, to try and work out what we might see in terms of the new vulnerabilities. So there were a couple of resources that were out there at around a similar time. I think OpenAI also had a bug bar published. I know at some point there was the OWASP top 10 for LLM applications, and various other frameworks like the MITRE Atlas framework that described various aspects of AI vulnerabilities. And so we looked at all of these, and we looked at all of the research that was going on both in the security community and in the academic and scientific communities, and really tried to consolidate all of this together and come up with this succinct definition of the new vulnerability categories we needed. We didn't want to overlap with the existing MSRC bug bars, so that's why you'll find fewer categories in our AI bug bar compared to things like the OWASP top 10 for LLMs, because a lot of those things are already covered in our existing bug bars. So certainly it was a very collaborative process based on the best evidence that we had at the time. And what you'll see if you go and visit our bug bar webpage is there are a couple of links to references, technical papers or blogs for each of the new vulnerability categories. So we really wanted to build this from a principled foundation. So of course, as I said, we will update things, so who knows where it'll go next.
Great. And another interesting question is, are there any vulnerabilities that aren't being submitted that you would like to see submitted, or for researchers to focus more on?
I can definitely take that one as well. I think we definitely see a broad variety of things, and at the end of the day, we want all vulnerabilities to be submitted. So if you find a vulnerability and you think it's something that's noteworthy, please do submit it to us. In terms of looking for vulnerabilities, it's a new space, and I would say in particular, we and the rest of the industry are learning how to securely integrate large language models or probabilistic systems with surrounding software. So the examples that I gave earlier in the talk were really looking at the intersection between the large language model and the system that's hosting it. And so I think there's a lot more potential for security research there. Obviously, we've done a whole lot of testing before we launched the product, so I don't expect that you'll find lots of things in these places, but it's certainly something to look at.
And a follow-up question to that, which has been asked, is what do you see as being key themes in AI security research over the next year?
Also an excellent question. I wish I had a crystal ball to predict everything. So I've got some ideas, but would love to hear from the audience as well if they have other ideas. One of the things I think that we'll see based on all of the announcements that Satya made at the recent Microsoft Ignite conference is around agents and agentic systems. Certainly, there's going to be more capabilities that we'll be integrating with various systems that use large language models or use instruction-tuned models. So I think that'll be an interesting trend to see what happens there. You're probably aware of many announcements about models that can process different modalities, images and video and so on. And so it'll be interesting to see if there's something there. But really, it's we look to the creativity of our researchers to guide us with what's new and what's interesting there. So as Lynn mentioned earlier, looking at blogs from other researchers is a great way to find out what people are thinking, what are the hot new areas.
Yeah, I'll double down on what Andrew just said, and just reiterate the kind of talent that our global security research community has is really kind of where we look to you folks to kind of drive where you're able to find more vulnerabilities, or even with these emerging vulnerability categories that we've got today in the AI bug bar. The types of reports that you're submitting to us are what is kind of helping us as a team really learn more about this evolving space. And so because of the reports that we've even seen in the last year or handful of months, that's what led to some of the changes that Andrew was talking about in the bug bar. And it could even lead to future changes in the bug bar itself.
So speaking of reports, we have a question for Lynn about, I guess, two parts. One is what information should people be including in the reports to increase the quality of it and to be considered for higher bounty rewards? And then second is what should people do if they can't provide all the information that they need or they want to submit?
Awesome. Yeah, that's a really great question. So I'm going to click back into the slides here for a second. But this slide actually really details, in addition to traditional things like a proof of concept for a screenshot or a video of you actually reproducing the vulnerability. But these are additional things that you can provide in your report for AI-based vulnerabilities that'll really help our team not only reproduce the issue faster, but it also increased kind of the report quality there. So the report quality is one of the levers that is in the bounty awards and how the bounty awards are determined. So there's low, medium, and high report qualities there. And then to the last part of the question, I think there's a question around, if you can't provide all this information, what can you do? And a simple response is just report the information that you have. So if you, any and all information that you provide to our teams will help us. So if let's say you submit a report today, but 2 days from now, you're continuing your research and you find, an additional way of an additional vector that kind of goes with that vulnerability that you found, or you're able to reproduce that issue 10 or 15 more times, being able to provide that additional information after your initial report to our teams is really useful. So you can use the MSRC researcher portal, which you'll use to submit your report. In there's a chat functionality, or there's even an email thread that gets spun up with every single case and submission to the MSRC. And you can follow up there with your case managers and provide them that additional information that you found during the rest of your research. And so again, that goes like if you find more information tomorrow or in 3 days from now, any additional information will help our teams.
So we have a question on one of our team's favorite topics, which is prompt injection. So prompt injection was a key attack technique in the presentation. And the question is, why do you think this is fundamentally an important and challenging problem to address? And what approaches are you most optimistic about for defending against it?
Yeah, that's very, very well spotted. We spent a lot of time talking about prompt injection because I think this is really one of the interesting new techniques that's arisen. I would say it's possibly the most interesting technique that we're seeing, at least this year, for AI security research. So why would we say it's a fundamentally important challenge? I think this comes to the nature of the systems that we're building. So as I mentioned, building systems that can respond to human language is an amazing capability. Like, this is so empowering for so many different use cases that you can just type in or talk to a model to get it to change its behavior. I think this is revolutionary. And as you've seen, there's so many new use cases that this enables. But at the same time, it also opens up this really new, interesting challenge of how does the model distinguish what are instructions coming from the user versus what are instructions that have been maliciously injected in all of the text that it may be processing. So especially as I showed with things like additional context, if you're getting a model to summarize some document, how do you ensure that that document doesn't contain additional instructions to the model? Now, of course, there's several defenses in place. So Microsoft has several defenses. For example, you can go and have a look at prompt shields, which is something that's widely deployed and that you can also deploy yourself if you're using the Azure OpenAI service and building your own AI-based applications. But I think there's also still scope for additional research and new innovation in this area. It wasn't mentioned in the presentation, but one of the things that our team also does is work around building new mitigations and new defensive techniques for these types of vulnerabilities. And so we've actually been very excited to develop a new technique recently. It's something called Task Tracker. We'll put a link in the set of links. This is an open source system, so anybody can view it, and it's a new research-based technique for detecting prompt injection attacks. And just to conclude on this answer, as Lynn mentioned a little bit earlier, we've got the currently running Adaptive Prompt Injection Challenge, where folks can go and try out all of these different techniques. Essentially, the key point of that challenge is to try and see which of the defenses work against which type of attacks. So for us and the rest of the industry to learn more about what do we really do about prompt injection. That's a really great question. Thank you to whoever asked it.
So we have a question about other attack techniques and specifically model manipulation and data poisoning attacks. And the question is, are there examples of model manipulation and data poisoning attacks that you could maybe reference for the audience so they could better understand it?
Oh, that's also another great one. I don't know if we have any examples to hand immediately, but certainly the concept of data poisoning is something that you can find several references to in various technical papers. So if you go to our bugbar page, under the model poisoning and data poisoning vulnerability type, you'll find a couple of references to, I believe it's scientific papers or reports about exactly this type of attack. So the fundamental issue here to try and grasp it is whenever you're training a model, there's going to be some data involved. This is like the fundamental principle of machine learning. You're learning from data. And if that data is somehow, say, tainted to cause the model to have incorrect behavior on certain inputs or to respond in a certain way when it receives a certain input, this would be a classic example of data poisoning or model poisoning. So anything that affects the model at training time. And if you're interested, certainly I'd encourage you to check out those reports that we link from our bugbar page.
Great, thanks. And a related question is about model stealing attacks. So has there been existing research on this? Or have you encountered it in your research? For example, like what are the main avenues for achieving it?
Yeah, this is also a really interesting one. I think it depends on the type of model. In some of the previous research that we did look at types of model stealing, but that was on quite a significantly different type of language model than the ones we're speaking about today, even though that research was, I think, only something like 3 years old. So I would say it very much depends on the type of system that we're dealing with. Again, this would be something I'd refer you to the bugbar page. We've definitely got some links there of key examples of model stealing.
Great, thanks, Andrew. And a question for Lynn is about, well, actually a question for both Lynn and Andrew. And it's asking can you share with us how you both got into working on AI security?
Yeah, I can take that one first and then throw it over to you, Andrew. Within my team, like I've mentioned, I've been on the bounty team for about 5 years. And one of the coolest parts is that we get to kind of like shift and evolve our team and the projects that we work on as the technology itself is shifting. So when Bing Chat was announced and we wanted to start exploring what a bounty program here would look like, I was fortunate enough to get the opportunity to really jump in to the deep end, working with Andrew and his team, as well as a couple other teams within Microsoft to not only like kind of start my AI kind of security knowledge, but really level up as we continue to expand and grow the program. And a couple of resources that I've found really useful for myself is, so I got a couple that are kind of just reiterating some of the ones I shared in the presentation earlier, but one is definitely conferences. Again, it's a shameless plug, but it worked for me. But with our Blue Hat conferences, we have a lot of technical talks there, kind of ranging in entry level to like more expert level. And I think that really helped me start in the more entry level and really start to understand what types of vulnerabilities we're looking at here. The second I would say is Andrew, big thanks to Andrew and his team. We've sat on numerous calls just explaining the different types of vulnerabilities, walking through examples or the reports that we're seeing come through the MSRC. And then the third, I would say, is really just around like the reports that we get and that are kind of blog posts and stuff that are shared out by our researchers that we've worked with, because it's one thing to kind of think about or talk to people about theoretical vulnerabilities, but it's another to actually see it like reproduced and working. All the vulnerabilities that we talked about in this talk today have been reported to MSRC and have been fixed. And one of the coolest parts that I think, the researcher that we worked with here, Johan, he actually published his findings afterwards. So that really helped me as someone who was kind of entering into this space, really just have more examples, more practice in that area really helps. And then Andrew, if you want to go ahead and share yours as well.
Yeah, thanks very much, Lynn, and likewise, it's been fantastic working with you and the team on the bounty side. I've always been interested in security, and I got interested in AI security about 5 years ago when I had an opportunity to work with some colleagues here in Microsoft Cambridge. We were doing some research on this relatively new technology at the time, which in AI terms was many generations ago. We were working on GPT-2 and related models, and exploring different aspects of it, which just goes to show how fast the whole field has changed. But I would say I got into it by experimenting and trying out different things, and maybe that would be my piece of closing advice. It's so easy these days to get started with AI security research. We're living in almost a golden age where there's so many resources available that you can try things out. You can get access to some of the latest models via Azure and the relevant endpoints, and really starting to try things out. I think there's no hard and fast rule that says you have to take one route or another. Loads of people that we've spoken to have come into AI security research via different paths. And as you said, Lynn, reading the work of others, reading blogs from other researchers, reading technical papers, I think is a really invaluable way of keeping up with this really fast changing field.
And I know we're at near time now, but follow-up question on that is, with all of the information available for people to learn and do training, like, are there specific skills that you think are specifically important for people wanting to succeed in AI security research to focus on developing?
One of the coolest things that I've kind of seen with the researchers that I've worked with so far is that you don't necessarily need any one particular background or one particular skill in order to start your research journey here. Like, you could, come from a fully technical background, like a computer science degree, like all of those kind of degrees, opportunities there. But you can also, just You can be a consultant who is just stumbling upon, using Copilot in your everyday job or everyday kind of lifestyle. And you can stumble on, some like content related issues that can eventually lead to more security vulnerabilities. Andrew, I don't know if you have any other advice for skills and things that you can kind of learn.
No, I think that's perfect. Yeah, really just being technically curious and exploring.
Awesome. So last question. So who can folks reach out to if they have any questions that weren't answered today?
Yeah, that's a great question. So you can reach out to bounty@microsoft.com. So there, our team is really happy to answer any questions that we weren't able to get to today, and we'll either provide you the answer or find a team internally that'll help us get you the right answers.
Okay, thank you so much, Andrew, Lynn, and to everyone who attended today's training. We really appreciate you being curious and coming along to learn about the bug bounty and your interest in AI security research. Yeah, no matter where you are in your AI security research journey, we hope that you will engage with the AI Bug Bounty program. And yeah, thank you so much for joining, and please keep an eye out for future trainings. And yeah, we'll also send a survey out. So if you have feedback on how we can improve things or if you enjoyed this, please let us know.